information on that. It's similarly worded, but it asks for a different question, or it wants a different answer based on the same initial conditions. Now, what we have here is an interior, we're summing up the interior angles in a convex polygon. Y'all, in a convex polygon is just nothing more than a polygon where any 2 points within the polygon are connected by a line segment that remains in the polygon. That's what convex means. But the big takeaway about a convex polygon is any angle in a convex polygon is less than a straight angle or 180 degrees. Now, so the question is, how many sides does the polygon have under these circumstances? Because we have an individual that summed up the angles and mistakenly left out one of the angles and got an erroneous value. His calculations are correct other than just forgetting to sum one of the angles. So one of the angles is missing in the sum. Now, so let's get going on this thing. Now, probably the main result I'd sort of like to semi-establish before we do this is this result right here that looks a little weird. But think of a square. A square is certainly an example of a polygon. It has 4 angles. Each of the angles are 90 degrees. So the sum of the angles in a square is 360, certainly, right? But notice that this square, you know, you have a 90-degree angle here, 90-degree angle here. So this is 360 total degrees, right? Interior angles sum up to 360 degrees. But notice that we can split the square into just 2 triangles. And it's well known that a triangle has 180 degrees. So this triangle, then the sum of this angle, and this angle is 180 degrees. But notice that we have 4 sides here. So it's real easy to believe the result here, 4 minus 2. Times 180, and that's degrees, of course, certainly equals to the 360 that we know is true in advance, right? So again, 4 is the number of sides of, and I wouldn't call this a proof, but hopefully it's convincing. It's the number of sides, and it justifies the existence of this more general result where it's not symmetric, the angles aren't the same or anything, but we know that n minus 2 times 180 is going to give you the sum of the interior angles. And that's essentially because there's 2 less triangles than sides in any polygon, okay? Now, a couple of observations right here once we get this out of the way. This fact right here, that any angle has to be less than 180 degrees, along with this statement right here, leads us to the conclusion that you have to have a multiple of 180, okay, that is strictly greater than 217, but it has to be the smallest one possible. And so this is just some arithmetic right here. This is just some arithmetic. This is too small, but this gets it done. 12 times 180 is equal to 260, which is greater than the 2017. See, we're trying to make up the ground about the angle that was omitted in the calculation. So what we can see right here is this must equal to 12 times 180. I'm writing it like that for a reason, folks, because you can see right here when you divide 180, both sides by 180, let me make sure that's understood, y'all. That's a multiplication going on right there. Dividing both sides by 180 just leads to n minus 2 equals 12. And of course, that results in n equals 14. So there's 14 sides. It's kind of interesting to me that it's based on, I guess you would call this just integer or natural number arithmetic. Okay, y'all, that is the answer to the question. And notice we have enough information here to figure out the angle too. It doesn't take much work to see that the angle would be what you would need 143 right here for x. If that were the question, I think that was the question in the competition, but x is actually equal to 143 if they wanted to know what the angle was that was left out of the calculation. Okay, but again, this is the answer that was asked in this particular question. Hope you enjoy it. Let me know what you think.